Hello everybody, Sanir, engineer, MBA, and investor. And in today's video, I want to talk about Natures.com article on CRISPR calling it a knockout run for CRISPR sales. And I thought to myself, you know what? I think it's worth looking into this paper. One, because I made a promise earlier this year that I would be making more videos on research papers rather than actual stock news and specific companies news. And two, I think there's a lot to learn here. There are a couple of key points here, and I think I want to bring this up here and, of course, have a great video discussion type on this beautiful Sunday here in Toronto. So, yesterday was really rainy, so wherever you are, hopefully it is sunny and bright because it is a long weekend here in Canada for Victoria's Day tomorrow. But what a beautiful day so far. But, anyways, jumping into the video. So subtitles is the continuing optimization of safety applicability of CRISPR for ex vivo genome editing will broaden the prospects of cell therapies. Okay, we'll go through the article here. So going through a little bit of history here. We're not gonna spend too much time here. But this part here is important actually. It is widely expected that the FDA will give the green light to using autologous CD34 human stem cells and progenitor cells edited ex vivo via CRISPR-Cas9 for the treatment of beta thalassemia and sickle cell disease. The cell product developed by Vertex and CRISPR Therapeutics leverages electroporated Cas9 to knock down BCLA11A, a gene repressing the production of fetal hemoglobin. So we go through this here. This issue of Nature Biomedical Engineering includes the latest example. In the article, David Liu and colleagues show that prime editing can efficiently correct the sickle cell allele to produce wild type hemoglobin in human. Okay. Yeah, so this paper actually, I'm pretty sure we covered this paper. Prime editing rather, is a new CRISPR modality first reported by Liu and collaborators in 2019. Of course, we have Prime Medicine as a public company that you can invest in today if you're really, really interested and really following this technology and if you're betting big on it. Beyond safety factors, there are consideration of efficiency, durability, and manufacturing that are being worked on to improve traceability of CRISPR technology for ex vivo editing of therapeutic cells. Okay. So cost-effective methods for manufacturing and quality control. So I think this is important because we often forget that there's a whole manufacturing side of things. That's why Beam Therapeutics was investing so much in their technology. That's why CRISPR Therapeutics were building facilities and preparing for their launch for Exa-Cell CTX001. Ross and Wilson and colleagues now show a gentler, simpler, cheaper, more efficient method to producing cell therapy based on priming human T cells. The peptides were okay. All right. I mean, this is talking about a paper here. Show efficiency at low cellular toxicity of the delivery Cas9, Cas12 nuclease. Okay, they're fusing that into T cells. Okay. All right. Retroviruses can be used to engineer primary human cells. Okay. I don't know how to pronounce the name, and co-authors now report a method for knock-in and stable expression of large payloads. It uses and integrates deficient lentivirus to insert a encoded payload upstream of an endogenous essential gene, followed by the delivery of CRISPR ribonucleoprotein via electroporation. Okay. Hey, was this article this one? Hold on, let me check this article. No, never mind. This is a new article. Okay, so The authors here in the other paragraph, they said they showed optimal extension that led to windows of Cas9 activity associated with low cytotoxicity. So basically, finding ways to be more efficient, reduce risk of, failures, reduce cytotoxicity. I think that's the big feedback right now with the CRISPR-Cas9 in CRISPR therapeutics, for example, the cytotoxicity and the risk of failures, right? The risk of getting the wrong combination there and messing up the gene and introducing an issue that you weren't supposed to. Cell therapies and T-cell immunotherapies for treating hemoglobins, B-cell cancers required. Okay, yeah, you see. So this is what I was talking about. So these T-cells therapies, and even in the CAR T space, you actually need extensive toxic chemotherapy, right, before transplantation of the cells to kill defective stem cells, right? So you actually have to go through a form of toxicity there, and that messes up the body in a sense, right? And this is the only feedback a lot of people have on CRISPR therapeutics program right now that is expected to be FDA approved. This is the problem, right? And they're basically saying in this paper there are other ways to basically prevent that happening, and there's new technologies allowing that to be more safer, more efficient, and less harmful to the body in long term and short term, right? Yet the technological innovation highlighted could be in principle be further developed to make it possible to safely engineer in vivo. That would be an utter knockout. So in vivo, of course, we're talking about companies like NTLA, right? So there's lots of things here. It's an interesting paper to say the least. My only comment, Prime Medicine, I saw recently Prime Medicine, and I may make a video on this. Alphabet, which obviously parent company of Google, actually sold their shares recently for Prime Medicine, which is sort of one of those big red flags, Prime Medicine being a company so early in the cycle and having their shares sold by a company like Alphabet, who's supposed to be their biggest or one of the biggest investors, at least when they were private. So I don't know. That's completely unrelated to this article, though. This article, I really like this article because it sort of reminds you that there's so much there to do just with CRISPR, with the safety. When you look at ex vivo, what can in vivo bring in? What can you prevent that? I don't really necessarily. I think this article just maybe should have done a better job just distinguishing that ex vivo actually has a place in genome editing, specifically ex vivo. And of course, in vivo makes more sense in others. I mean, the great analogy I have, and I know this is the analogy that Dr. Liu beat down in ARK Invest podcast a couple of years ago, is that, yes, airplanes are obviously faster than cars, but you're not going to take an airplane to go from your hometown to maybe in the suburb, just 45 minutes away. That's dumb. You're not going to do that. Not just in terms of delays and so on, just in terms of cost. And yeah, so I just don't see that happening, right? But nonetheless, hope you guys appreciated this video, guys. Thank you so much for watching. I'll see you guys in the next video. Have a beautiful Sunday. Hopefully, wherever you are, it is beautiful. Like this video if you found value, subscribe if you're not. And let me know in the comments, guys, where do you think CRISPR could be heading with all these safety? Do you think in vivo could replace it? Do you think ex vivo is here to stay? Let me know. I'll see you guys in the next video. Thank you.